Learning about something called function notation. Now, it is not something new. It's just a different way of writing what we used to write, okay? Do you guys remember when I said, like, if y equals mx plus b, whatever's already solved for, so whatever was on the left side of your equation was your dependent variable? You also saw one of those on your quiz today. Do we remember that? Yes. Now you're replacing that and you're saying, okay, we're going to write it in function notation. This is replacing our dependent variable, guys, okay? Write that in there. Dependent, if I could spell, dependent variable. Now, it's replacing the dependent, but what do we still have? We had dependent variables and what else? Independent. So our independent normally is x, right? It's going to stay as x. Now, function notation, do you guys look down here? It's written as f of x equals mx plus b. So our function is whatever the letter is in front of the x. So our function is technically f. And it relates to whatever your independent variable is, so x. So our function, f, is it in terms of x. So it's mx plus b. So what you're going to see is this letter that's in parentheses next to your function is going to get repeated on the right-hand side because it's your independent variable. It's whatever your inputs are. So what's going to happen is we're going to plug in numbers for x here, and we're going to replace them in our equation over here, okay? So I'm going to give you two other examples so you can kind of see what it looks like. Please put these on the left-hand side of your page. We're going to see a lot of the times g of x is a very common one as well, okay? And g of x, just to give you an example, could be equal to like 10x minus 4. And guys, some things to note. This is not saying, normally when we have something outside parentheses, it means multiply, right? This is not saying g times x. This is saying g is our function and it's in terms of x. And you'll notice, do you see how x repeats there on the right-hand side? It's because x is our independent variable. So if we plug something in for x, we're going to plug it into two spaces. Once in between these parentheses and another time over here on the right-hand side. Do you guys see that a little bit? We're going to do examples, but just so you get familiar. Another one you're going to see a lot is h of x, okay? Actually, let's change that. Put h of y. H of y. So now h is my function. Y is my independent variable. So when I write equals, I'm no longer going to have x on the right-hand side. What variable am I going to have? Y. Do you guys see that? Because y was inside the parentheses. So we can write like 7 minus 3y. You're going to see that variable repeated on the right-hand side because it changed what was inside the parentheses. Does that make sense? Now, our dependent variable is still the name of our function. So g, the function g would be our dependent variable. The function h would be our dependent variable, okay? We're going to do one example and then we're going to call it quits, okay? And we'll pick up tomorrow. So look down at example 1. It's given to us that the function f of x is equal to negative 4x plus 7. And we have to evaluate it when x equals 2 and x equals negative 2. Underline those two values in different colors. So use red for x equals 2 and use blue for x equals negative 2. So what we're going to say is okay, our function was f of x equals negative 4x plus 7. And the first one, we're going to replace every x with the number 2. So you're going to write f, put parentheses, put the number 2 equals negative 4. Replace that x with the number 2 plus 7. What this is saying is our function f with the input of 2 is going to be equal to negative 4 times 2 plus 7. Do you see how every time I saw an x, I just replaced it with a 2? This is where we're going to stop. We're going to pick up tomorrow. Times 2 plus 7. Did I tell you guys yesterday, this does not mean multiply these? Yes. Okay. This is a function f evaluated at what number? 2. Okay. So we're going to find out what the output is. What is negative 4 times 2, peeps? So we're going to rewrite this f of 2 equals negative 8 plus 7. Why did I multiply before I... It'll load. Just give it a second. Why did I multiply before I add, peeps? Order of operations, right? PEMDAS, right? Multiplication comes before addition, okay? So I know it's not loading. Guys, you should be writing down f of 2. So f parentheses 2 equals negative 8 plus 7. Then what's negative 8 plus 7 or 7 minus 8?
Negative 4, 2. Oh, wait.
Oh, it loaded. So we're going to get f of 2 equals negative 1. Input for this function. It was 2. So our input is going to be 2. And what was the output when we plugged in 2? Negative 1. So my coordinate is 2 comma negative 1. 2 comma negative 1. What's up, Jonathan? The f. So f is our function, right? F is what's changing our input to what creates our output, right? So our function is negative 4x plus 7. So when we plugged in 2 to x, it became negative 1. Let's see the second example and see if you have the same question, okay? So change your color. For the second one, what are we testing? What are we making x here, guys? Negative 2. So we're going to write f evaluated at negative 2. Should be equal to negative 4 times negative 2 plus 7. Okay, peeps, who's good with those negatives? What's negative 4 times negative 2? Positive 8. So we're going to get f of negative 2 equals positive 8 plus 7. 8 plus 7? 15. Ask yourself, what was my input here? Negative 2. And my output became 15. Do you see how that's a coordinate now? Jonathan, does that make sense? A little bit better? Okay. Okay, so let's shift over to B. What values are we plugging in for x now? Underline them with 3 different colors, peeps. I want you separating them so you can see the difference. So the first one I'm going to do in red, I'm going to plug in x equals negative 4. Who thinks they have the hang of it already and can walk me through that? Go ahead, Hunter.
So instead of x, you're going to place it with 4.
Good.
So it's going to be f and the parentheses 4.
Not 4.
Negative 4.
Negative 4, yep.
Equals 2 in parentheses negative 4.
Excellent.
Minus 5.
Good. What does that mean when the 2 is next to the parentheses?
It means
Good. So what am I going to get?
so it's going to be 4 f negative 4
Mhm.
equals negative 8 minus 5.
Good.
And it's going to be equals negative 3.
Try again.
Wait. Oh, my bad. What do you mean?
What's negative 8 minus 5?
Wait, am I wrong? Oh.
Negative 13. Why is it negative 13, guys? Are they both negative?
Yeah.
So what do I do with their values? Add them. 8 and 5 combined to give me 13, but it needs to be
Negative.
because they were both negative. Do we understand that? When do 2 negatives make a positive? Multiplication or division. Are we multiplying or dividing these? No, so we should stay negative. So what's my coordinate? Someone else. Very good, Hunter. What's my coordinate? Alicia? No. Thank you. We Gucci? Change colors. Next one is in blue. Someone walk me through the blue one. Josh?
So you have GX.
Wait, no, we're on F. What am I evaluating F at? What's the second one?
So F is 4. Or is, F would stay 4.
No,
Would it be positive?
No.
0.
It'd be 0.
it'd be 0. So F at 0 equals 2 times 0 minus 5. What's 2 times 0? So F of 0 equals 0 minus 5. What's 0 minus 5? So it's negative 5. So what's my coordinate? Who's been good with this? Who understands it? Nathan? Very good. 0 comma negative 5. When my input is 0, my output is negative 5. Josh? Where'd the 0 come from? So in the instructions, it said plug in negative 4, 0, and 3. So that's what we're plugging in here. Change your colors again for the last one. We're plugging in what for the last one? 3. So we're going to write f of 3 equals 2 times 3 minus 5 equals 6 minus 5, which is 1. So what's my coordinate? 3, 1. Jonathan, you had a question? What? You want to do this one? Is it making sense, people? Are we sure? Any questions on any of these 3 that we just did? It's kind of similar to when we plugged in for x, right? When we had non-functions, like y equals, right? You want me to zoom in? Is that better? Okay. All right, those of you that are done copying down, I want you to try g on your own. Try g of x on your own. You're plugging in the same values for x, but it's a different function. Like g of x, letter C. Try letter C. Yep, just like I did in the previous one. And use the same colors. All right. The answers are up on the board for the second one. See if you got them right. And talk with the people that are next to you. If you got them, help out. If you didn't get them, ask for help. Go. First one, when you plugged in -4, you should have gotten g of -4 equals -4 minus 1. What's a -4, people? A positive 4. Minus 1 gives you 3. So that's where the 3 came from. We Gucci on the first one. Second one, when you plug in 0, you're going to get g of 0 equals -0 minus 1. What's -0? Still 0. What's 0 minus 1? -1. So 0, -1 was the second one. And for the last one, when you plugged in 3, you should have gotten g of 3 equals negative, and then in parentheses, 3 minus 1. What's negative times 3? -3. What's -3 minus 1? -4. Questions? Yeah.
For the second one, since it's, you can't make it a -0, right?
Correct. So 0 can't be positive or negative. It has no sign, right? So if it's a negative times 0, it's still going to stay 0. Good question. Yeah. When Sophia comes back. Okay. Moving on, guys. The second thing we're looking at is when we're using functions in word problems, okay? Very important stuff. So I'm going to walk you through the first one, and then I'm going to ask you guys to do the second one on your own. Check it out. It says, let f of t be the outside temperature in degrees Fahrenheit, t hours after 6 a.m. T hours after 6 a.m. So our function is a function of what variable? T. And t represents? The hours after 6, okay? Keep that in mind. Explain the meaning of each statement. So the first statement is f of 0 equals 58. They replaced t with what number? 0. So t is technically equal to 0. Do you guys see that? So if we're 0 hours after 6 a.m., what time is it? It's 6 a.m. So at 6 a.m., our function f is equal to 58. At 6 a.m., our function is equal to 58. And our function represented what? What was f? Let f be the? No, let f be the temperature. So at 6 a.m., what do I know about the temperature? It's what? 58 degrees. At 6 a.m., the temperature is 58 degrees Fahrenheit. In the second one, f of 6 equals n. What is t in this example?
6.
So t is equal to 6. That means if we're 6 hours after 6 a.m., what time is it? 12 p.m. So at 12 p.m., the temperature, do we know the temperature? No. What is the temperature? N. The temperature is some unknown value, N, degrees Fahrenheit. Do you guys see how this is kind of working? Now, the last one is not an equal sign. What is it? An inequality, okay? So we have to treat that one a little bit different, okay? The last one says, let's start with f of 3. What is f of 3 saying? 3 hours after 6 a.m. So t is equal to 3. Do you guys agree? What is 3 hours after 6 a.m.? What time is it? So it's at 9 a.m. It's saying the temperature is less than. Do you guys agree? So the temperature at 9 a.m. is less than the temperature at what time? Not 2 p.m. 3 p.m. Why? Because t was equal to 9. 9 hours after 6 a.m. is 3 p.m. The temperature at 3. Let's read that again. If the temperature at 9 a.m. is less than the temperature at 3 p.m., what happened during the day? It got hotter. That is the inference I need you to make. So I need you to write down during the day. You can write it however you want. You can write it got hotter, the temperature increased, it got warmer, the sun came out, it warmed up everything, whatever you want to write there, but you need to understand that the temperature went up during the day. So during the day, the temperature, I'm going to write the temperature increased. And I'll put in parentheses, it got hotter or warmer. Are there any questions on A, B, or C? Okay. The example down below is the exact same thing, but they changed the starting time. What's the new starting time in the example down below? 9 a.m. Try those 4 examples. Let's see what we get. Go. Completely understand the first one. F of 4 equals 75. Isabella E.
So t equals 4. So,
Good.
9 plus 4 is 13 plus 1. Yeah.
Good. So at 1 p.m.
At 1 p.m. it is 75 degrees Fahrenheit.
Excellent. Very good. Okay. So 4 hours after 9 a.m. would be 1 p.m. and it is 75 degrees Fahrenheit. B is a little bit trickier. Does anyone think they got B? Bruce? Ah, you said at 9 a.m.? No. Gabby?
T is equal to M.
Good. T is equal to M.
M hours after 9.
Good. M hours after 9 a.m. What's the temperature?
The temperature will be 7 degrees.
Good. The temperature is 70 degrees Fahrenheit. So at some point after 9 a.m., the temperature will reach 70. Do we know what time that happens though? No, because M is still an unknown variable, okay? So you're just going to put M hours after 9 a.m., the temperature is 70, okay? C. What do you think, Nathan?
So you enter and that's just it's 11 a.m.
Okay,
and it's equal to 6 p.m.
okay.
So starting 11 a.m. and 6 p.m. it
Excellent. So the temperature is the same at these two times, at 11 a.m. and at 9 a.m. What? 6 p.m.
I'm like so confused on this.
You're confused on that one? Okay. So do you agree that T was equal to 2 here?
Yeah.
What's 2 hours after 9?
11.
11. What's 9 hours after 9? 6 p.m. Do you agree with that?
Yeah.
So it's saying the temperatures are equal to each other at these two times. So our function represents the temperature, right? So if the temperature at 11 is equal to the temperature at 6, we know that the temperatures are the same at 11 and 6. But we don't know the number. We don't know exactly what temperature it was. It could have been 60 degrees, it could have been 70, could have been 75, but we do know that it's the same temperature at both those times. Does that help?
Yeah.
Okay. D. Jonathan?
I'll put 3 p.m. is
3.
greater than 9 a.m.
So the temperature at 3 p.m. is greater than,
I'll put at 3 p.m. it was warmer than 9 a.m.
9 a.m. Jonathan is correct. What inference can we make about the temperature during the day? Gabby? No. Kyle? That it decreased? So the temperature at 3 p.m. is greater than the temperature at 9 a.m. Let's pick two temperatures. If the temperature at 3 is 80 and the temperature at 9 was 70, is the 3 p.m. temperature bigger than the at 9 a.m.? What happened during the day? It got warmer. Do you see the difference? So during the day, the temperature went up. Okay, we will finish these tomorrow. Start packing up. Okay, so we also need to figure out, sometimes we have to find the value of x when we only know the output. So in this next example, in example 3, letter A, we're given h of x, but then we're told, okay, our output needs to be -7. Figure out what input would cause this. So how we do this is instead of replacing x, we're going to replace the function h of x, so the entire left-hand side. So we're going to rewrite this as -7, replacing -7 with h of x, equals 2/3x minus 5. So everything stayed the same, but instead of h of x, I'm now writing -7. Okay, if we want to solve this, we want our variable to be on the left-hand side. I'm going to rewrite this, flipping my equation. So 2/3x minus 5 equals -7. I can do that because this is equal, so whatever's on the left is equal to what's on the right. And I can reverse the order, okay? Now, what I need to do is I need to add 5 to both sides, move all your constants to the right, keep your variables on the left. So we add 5 to both sides, we're gonna get 2/3x equals -7 plus 5 is going to stay negative. It's going to be -2. And then last but not least, you multiply by the reciprocal to get rid of this fraction. If I multiply by 3/2, I'm going to get 6/6, which is just 1. These are going to cancel. It's just going to be x equals, I have to multiply this side by 3/2 as well. Remember, this -2 is technically -2/1. -2 times 3 gives me -6, and one times 2 gives me +2. Now I have -6/2, which is -3. So x is going to be equal to -3. Watch how I want you to write your answer. -3 is what x is, but it caused our function to be -7. I want you to write that h of -3 equals -7 because we're looking for the input that will produce the output of -7. You could always go back and check this by taking your value that you get for x and plugging it back into the x over here. If you plug it back into the original, you should get -7 once you process it. Okay. B, we've got f of x equals 6x plus 9, where f of x is equal to 21. We're going to take this 21, replace it with the f of x. So our equation becomes 21 equals 6x plus 9. Again, my variable's on the right. I want to reverse the order. I'm going to write 6x plus 9 over here, put the equals in the same spot, and the 21 now goes on the right side, okay? If you're confused on this step, just look at everything on the left is moved to the right, and everything on the left, or on the right, is moved to the left, okay? They're in the same order, same operations, nothing changed. Now we start to move our constants to the right-hand side because we want to keep variables on the left. So subtract 9, subtract 9. We've got 6x equals 21 minus 9 is going to give me 12. And then my last step is to divide by 6. Divide by 6. So we're going to get x equals 2. Once we get that value, make sure you rewrite it as f. We plugged in 2, and we got 21. This is the answer I'm looking for. Okay, last but not least, guys, we are going to do some graphing. So go ahead and look at example 4, graph the linear function by completing the function table. Guys, on a test or a quiz, I expect 3 values in this table, okay? For you guys, we're going to do 5 as our example, but on the test or the quiz, I expect 3 only, okay? If you do 5, it's not wrong, okay? You'll still get the right answer, but I do want you to have at least 3. So if you want to make a note of that, put 3 points on test or quiz, okay? All right, so what we're starting with is we're given this function, f of x equals 2x plus 5, and we're going to plug in all of these values for x and see what f of x gives us. So for our first one, we've got f, and we're evaluating at -2. I'm replacing x with a -2, and that's going to be 2. We're replacing x with -2 plus 5. So we have 2 times -2, which gives us -4. Add 5 to that. -4 plus 5 is going to give us a +1. So my coordinate has your input first. My input was this -2. So we're going to write -2, comma, and our output, we got 1, the 1 from over here. So -2, comma 1 is our first point. Find -2, 1, and put a dot there. That's our first point. Our second point is when we plug in -1. So f of -1 equals 2 times -1 plus 5. 2 times -1 gives me -2. Add 5 to it. You get a +3. So my next point is -1, comma 3. Go to the left one, up 3. There's my next point. Moving on, if we plug in 0, you're going to get f of 0 equals 2 times 0 plus 5. You're going to get 2 times 0, which is 0, plus 5, you get 5. So we're going to have 0, comma 5. Okay, so once we get that, we also have to plug in that point, 0, comma 5. This is where I'm going to stop, okay? You should notice that all 3 of your points should be in a line. You are going to connect the line. And make sure you draw arrowheads on both ends because this function goes on forever, okay? Now, in the past, we haven't been connecting them, okay? And that was when we were dealing with word problems. So when there was a discrete domain. Whenever you're given a linear function, okay, from here on out, you are going to draw the line through them. The reason being is we are not discussing a word problem here. This function will continue on forever. We could have picked any value for x. Our domain was not restricted to certain values, okay? So we are going to draw the line through it. We're going to do one more example, and then that'll be it. So go down to letter C. We've got g of x equals -x plus 4. What we're going to do is plug in our values. So we're going to do g of -2 equals -2 plus 4. This will give me a +2 plus 4 will give me 6. So our first point is -2, comma 6. Our second point is going to be g of -1 equals -1 plus 4. That's going to be a +1 plus 4, which will give me 5. My next point is -1, comma 5. I move on. I do g of 0. That's going to be -0 plus 4. Remember, 0 is neither positive nor negative. So it's just 0 plus 4, which is 4. This is going to be 0, comma 4. And let's plot it. So it was -2, comma 6. in red, -1, 5, and 0, 4 should create a straight line. I see all my points are in line. I'm going to draw the line that goes through them. And that's my line. Make sure the arrowheads go on it, and we're perfect.